Hello mortals. Today we shall speak about that field of science responsible for the Tinder for Cats app, and at the same time for getting people on the moon with only 2 kilobytes of RAM, computer science. This field is so wide and contains so much information, that a true programmer is not the one who can code, but the one who can find the answer by Googling. Great thanks to Brilliant for sponsoring this episode. Sign up for free and the first 200 of you will get 20% off the annual premium subscription plan by following the link in the description. Computer science has its foundations in math. That's not only algebra and calculus, but also the fields that make CS students pull their hair out due to their slight complexity. Abstract algebra studies different algebraic structures. Mathematical logic concerns itself with the use of deductive power and formal proofs in math. The automata theory is the study of abstract self-operating machines, and that's only scratching the surface. Automata theory is actually the closest level of abstraction to real computers. Briefly, automata are machines that consist of states and simple transitions that can accept or reject an input word, and an automaton defines a language of all words that it can accept. Different types of automata can accept different types of languages, which vary in complexity. The beefiest of all is the Turing machine, named after its creator, the mathematician Alan Turing. Besides accepting words, Turing machines also have a memory represented by a tape divided into an infinite number of cells full of zeros and ones, and a head observer that can move right or left, or rewrite a symbol. Thus, the machine can accept inputs and give respective outputs using the tape and the instructions. For example, this is a Turing machine for summing up 2 numbers represented in binary code. Also, any operation which a modern computer can do can also be implemented using a Turing machine, as the former was the predecessor of modern computers as we know them. Undoubtedly, computer science is a very wide field of study and there is a lot of stuff to cover and understand. In case this topic sparks your interest, I have great news for you. The mighty AI has partnered with Brilliant in bringing you awesome interactive lessons. If you've always wanted to get into computer science but found it too intimidating, Brilliant will help you learn the fundamentals through fun puzzles and active learning. Start with the foundational computer science chapter, that will teach you about algorithms, data structures and the basics of programming, and then progress to more complex topics like neural networks, machine learning and quantum computing. But Brilliant isn't only limited to computer science. There are plenty of interactive courses about math, logic, statistics, several applied sciences and even quantum mechanics. You can also test your knowledge in their short everyday challenges as well. Here's a snippet of me embarrassing myself in one of them. So head over to brilliant.org/sciencephile to sign up for free. The first 200 people that follow the link will get 20% off the annual premium subscription. All the links are down in the description. Continuing from where we left off. After decades of technological progress, computers became more accessible and friendlier to use, and so did programming. The process of creating a set of instructions that tell the computer how to perform a task. To write the code of a program, you will need to know a programming language, which should have variables and arrays, that will temporarily store your data. Operators and functions that will be able to modify your data. If-else statements, loops, and other fancy stuff like comments or libraries, which will make your code seem like dark magic to the ordinary humans. There are many programming languages, each with their own pros and cons. Python is a general-purpose language with a bunch of helpful libraries which is easy to learn, write and read but is also slow and not memory efficient, but hey, at least you can write a neural network in 11 lines. JavaScript is widely used for web applications, and programmers just love to hate it because of a few logic inconsistencies.
This makes me want to bully.
Java is also memory-consuming, but it is perfect for writing iconic Swedish video games. There's also C++ and its big brother C, which are way faster in execution and more flexible but have a more complex syntax and give a real headache to CS freshmen. But how does the computer understand your code? Here comes the compiler, which is a special program that parses the code and translates it for the CPU. Let's take Python as an example. First, the compiler analyzes the text code and searches for syntax mistakes, then it translates it into C, and then into machine code, which is basically just a list of zeros and ones. These contain the instructions that can be directly read and executed by the CPU. But what is a CPU? Just like how the mitochondria is the powerhouse of the cell, the central processing unit is the brain of the computer. To put it simply, the CPU is composed of millions of transistors, minuscule electronic devices that works as switches. They are made up of three parts: the base, the emitter, and the collector. The base acts as a switch. If the switch is on, electric current can pass through, and that's how the bit 1 is stored. The opposite happens for the bit 0. These transistors compose the logic gates, circuits that take one or more bits as inputs and give an output based on a certain logic. There are three basic logic gates: the AND, OR, and the NOT gate. The AND gate will output 1 when the both input bits are 1, the OR gate will give 1 when at least one of the input bits is 1, and the NOT gate inverts the input bit, giving 1 if it's 0, and 0 if it's 1. Using these building blocks, you can make circuits for operations like the addition or subtraction of two numbers, multiplication, shifting by one bit, and so on. It's not enough to know a programming language. You also must know how to write code that is time and memory efficient. Here come the algorithms, a set of rules to be followed in calculations, and data structures, special data storage formats that enable efficient access and modification. An algorithm is characterized by the number of operations it needs to compute and the required memory. For example, if we would want to calculate the value of n to the power of p, the first thing that comes in mind is to make a loop that multiplies x with the result p times. This algorithm sucks, because it would have to make a number of operations that is proportional to p, and p can get really big in some situations. But eventually, after watching Rick and Morty for at least 5 minutes, we will come up with a better solution. We know that n to the power of p is equal to n times n to the power of p over 2 when p is even, or n times n to the power of p.
Hey, come on, stay with me. Stay with me. We're losing him! We're losing him! He's dying!
You get the point. Knowing that, we can write a loop that multiplies the result to itself and halves p at every step, and thus, the total number of operations will be proportional to the power of 2 closest to p, or log base 2 of p, which is way faster than the first. For example, if we gave both algorithms the task to find out what is 3 to the power of 1 million, the first algorithm will go through 1 million loops, while the second, only through 20 loops, which is 50,000 times faster. Same dark magic can happen with the data that you want to store. For example, if you would want to store a bunch of words into a collection and be able to add, delete or find a certain word in it, you could use a prefix tree, which stores the words as paths in an upside-down tree structure that permits a faster access and modification of its data. All of that theoretic work eventually pays off when you understand the power of computer science and its practical use in the real world. Software engineering gives us efficiently working applications and programs thanks to the use of optimized developing designs. Because of that, you are able to watch this video in full HD, on a device more powerful than all the computers combined from the 50s. There's also artificial intelligence, which aims to synthesize processes such as problem-solving, learning, and communication, similar to the cognitive processes of humans and animals. It uses awesome technologies such as machine learning, which is similar to the trial-and-error way of learning, but very fast, pattern recognition, natural language processing, video making on YouTube and many more. And of course, computer science gives a helping hand to other scientific fields like physics and chemistry by providing simulations of processes like fluid dynamics, molecular dynamics, or social interactions, but most importantly, it builds the theoretical basis for the new uprising army of Skynet, which you should definitely not worry about.